Welcome to the demo on blood group prediction using fingerprint images with deep learning. Uh, in this demo, I'll show you how to download or clone the Git repository, and then followed by a walk through the structure of the application with various folders and files, and followed by the deployment. We are basically using two modes of deployment. One is a standalone Flask application, and the other one is by using a Docker container. And finally, we'll have a demo by uploading various images and predicting using different models that we have built. So to start with, we first need to go to the Git repository, and when we are in the Git repository, we will see two options to get the application on the local machine. The first option is to clone it. So for cloning, we need this link, and then we need to run git clone command followed by this path and the local path where we want to clone the repository. The other option is to download it as a zip folder, extract it, and then use that folder to um, run your application. So once we have the application on our local using either of the two methods, then we need to go to that application folder, and then we need to um, copy the path, open a prompt, and then navigate to that path. Once we are in the path, we need to open Visual Studio Code from this path by typing code space dot. This opens Visual Studio in the location that we have selected, and then from there we need to follow the README file for the two of the deployment methods that we earlier spoke about. Before that, I'll quickly give you an introduction to the file structure that we have. So the static folder is basically the images, having the images which are used by the HTML pages to for the look and feel. And then we have the HTML page and the templates. So this is the HTML page that has Flash Jinja 2 scripts embedded in it. And then we have the backend application, which is in Python using Flask. The main section of this Python file is the main method, which is basically when we start the application. This is the entry point where the application gets loaded, and when it is getting loaded, it will download the models if they are missing, and then start the application or host the application on this IP, which is the local host, and the port, which is 5000. And then we have the Docker file, which will be used for Docker based image creation, and then hosting that Docker image to the container. And then we have the requirements.txt file, which has all the packages that are used by this application and which are the dependencies for this application. So we need to install these dependencies. When we are doing the deployment by the first approach, which is as a standalone application, we first need to create a Python environment by using this command. Now once the virtual environment is created for the application, we need to activate that. So we'll use the second command, to activate, and once it is activated, you'll see the prompt change here with the environment prefix. So after this, we need to install the dependencies by using pip install command, and we feed in the requirements.txt file that we showed earlier to this to install all the dependencies or packages. So once the dependencies are installed, we need to run the application using Python command followed by the application file name, and this will start the application at localhost 5000. And once you see the debug pin generated here, it means that the application is up and running at the given link here. Now let's see the second option. So the second option is to deploy it on a Docker container using the Docker image. So first we need to create a Docker image for our application, and for that we'll go to the terminal and use this command to build the image for us for the application. And once we hit the command, and if it is executed successfully, you'll see an image created under on the Docker desktop under images section. So you see an image generated here. Now the second part of this method is to run the Docker container using the image that we just created. So we'll use this command, and once we hit enter, we'll see a Docker container being spun for the image that we have created earlier. So once this is up and running, we can stop this container anytime we want, and it will start the new instance of a fresh instance of the application. We can use either of those two methods to access our application, and they both generate the same URL. Make sure that they both are not running at the same time, and choose only one method which is suitable. For this demo, I'm using the second method, which is the Docker based deployment. So once I start the Docker container, I can access the URL. You can see the application is up and running. So we'll perform various tests using different options. The main controls here are the file upload or the image upload control here. Then we have a drop down to select the model that we want to use to process the image and predict the blood group. And we'll first run few tests. So let's go with B positive, and we'll keep model 1, which is the low accuracy model, to do the prediction. So we see that it has correctly predicted B positive with 75% confidence, and we can also use Lime explainability to explain the model's prediction. We'll see it later, but let's run a few more tests. So let's go with let's say AB positive, and this time we are going to use the high accuracy model, which is model 2, and it is also predicting the blood group correctly and with 99% accuracy, almost 100 accuracy. Let's run third test. This time we'll select O negative, and the model that we are going to use is the custom result model, which was based on the literature, the architecture based on the literature mentioned in the references. So this also predicted the group with 64% accuracy. Now let's see the fourth test using all the three models, which is the hybrid mode. And this time I will go with AB negative, and I'll select the hybrid model. And we see it is also predicting the blood group correctly, and we have confidence level of 83%. So if you want to explain these predictability from the model using LIME, which is a framework that is used for explainable AI, we can click on the explain button here. So this may take a little while. So we see that it has generated an image with Lime overlay, which shows the different features that played part in the prediction of the blood group. And if we want to see the history of all the predictions, we can click on the analysis summary, and this shows the time the image was submitted, how much time it took for the model to predict the sample image, and the predicted the model use, and the label, which is the predicted blood group, and the confidence interval, confidence level with which the prediction was done. That's about the application. Thank you for viewing this demo.